Second question that we have, the wave equation is given. We need to find out the time period, wavelength, equation of velocity of particles and the speed of the particles at x is equal to 3, 5 and 10 centimeters at t is equal to 0.01 seconds. So this question has a lot of subparts. So the main thing you keep in mind here is, you look at the equation carefully and keep into mind the units which are given. So let us first find out the time period of this given wave. So the time period is equal to 2 pi by omega, where omega is the coefficient of t in the above equation. Therefore omega is equal to pi upon 0.01, t is equal to 2 pi upon pi into 0.01, that is equal to 0.02 seconds. So we get the first answer of the time period as 0.02 seconds. Now we need to find out the wavelength. Now the coefficient of x in the equation is k. Always compare this equation with y is equal to a sine omega t minus kx plus phi. Now the coefficient of x is k, where k is equal to 2 pi upon lambda. Therefore we get 2 pi upon lambda as 2 pi upon lambda is equal to pi upon 2.0 centimeters. Therefore lambda is equal to 4.0 centimeters. Therefore we get the second answer as lambda is equal to 4.0 centimeters. Now for the third part, we need to find out the equation of the velocity of the particles. So the equation of velocity of particles is obtained from this. So to find out the velocity of particles, we have to differentiate this with respect to, partial differentiate it with respect to t, that is del y by del t. This is because for any fixed x, we are trying to find out the velocity of the particle, that is at different times. That is, we fix the x and then we differentiate. That is known as the partial differentiation with respect to t. This comes out to be equal to 1.0 millimeters into minus pi upon 0.01 seconds into cos of pi x upon 2.0 centimeters minus pi t upon 0.01 seconds. So this we get as the equation of velocity of particles at any time t for fixed x. So we can now put in x, different values of x, to find out the velocity of the particle at that position x. So this is our third answer. Now for the fourth part, we need to find out the speed of the particles at x is equal to 3 centimeters, 5 centimeters and 7 centimeters at t is equal to 0.01 seconds. So let us find it out for the first one, 3 centimeters. On putting it here, we get this cos term as cos of 3 pi by 2 minus t is equal to 0.01 seconds gives us pi. This gives us a value of 0. Therefore the velocity, the speed of the particle at x is equal to 3 centimeters, at t is equal to 0.01 seconds is 0. Now there is a careful realization which you should have made here. Instead of putting all these values, you can see what the lambda is. Lambda is equal to 4 centimeters. So at t is equal to 0.01 seconds, the graph of y versus x would be something like this, where the particle at x is equal to 3 centimeters has a velocity of 0. That means the 3 centimeters particle is at its highest point. So this will be the 3 centimeters particle, which is at a distance of 3 centimeters from this point. Now the value of lambda is equal to 4 centimeters. Therefore this will be equal to 7 centimeters. This point, which is again at its highest point and has 0 velocity. The point at this will be 5 centimeters point. So we clearly see that all the particles at all these points, 3 centimeters, 5 centimeters and 7 centimeters, are at their extreme positions and thus will all have velocity equal to 0. You can also find out the answer by putting the values in this equation. You will get the same answer. So the answer for the fourth part is the speed of the particles at x is equal to 3, 5 and 10 centimeters at t is equal to 0.101 seconds is 0. So it is always very useful to draw the graph of the equation and solve it easily.